Today we will walk through how to use the buffer designer function of the expert buffer designer. First, you go to the home page and you start by clicking the start designing button, and then you click the designer tab, and here you'll have the option of choosing the buffer type. So here, for example, I can choose citrate as the buffer, and once you choose citrate as the buffer, then it gives you the option to specify the citrate concentration you see in this label here, and that is the total buffer concentration. And then it automatically gives you a recommended pH based on the pKa of citrate, and then it automatically picks the compounds to make the citrate buffer. And you can change the potential compound by changing the using this drop down here. For example, you can use sodium hydroxide instead of sodium citrate, but for now we're just going to leave with the default. You can also choose to add sodium chloride or choose none, but for now we'll leave it with the sodium chloride at 0.1 molar. And then when you click buffer design, it basically goes up to the server and it's able to calculate the buffer composition and give you the buffer summary. Now it also creates a solution list, and you see there is already a default solution here, but then the new buffer is added as another item in the list. Then the next thing you'll see is the composition of the buffer, which gives you the concentration of the citric acid, sodium chloride, and the sodium citrate. And then it was able to achieve a pH of 6.400. Then the next you'll see that it gives you the breakdown of the individual compounds in the buffer in terms of its molecular weight, the molar concentration, and the mass concentration, and then the citrate ion concentration in each of these solutions, as well as the other ion concentrations depending on what compound you're looking at. And then the next thing you notice is that you also get the next level of detail on each of these ions. For example, you can get the pKa of the citrate that it is using, all the 3 pKa's, and then the charge associated with each of those pKa's, and then the concentration breakdown of each of the charged species, and then the total concentration. And then what's also really interesting here is you can, in addition, get a compositional variability heat map, where on the y-axis you have the sodium citrate concentration, and on the x-axis you have the citric acid concentration. And if you vary the citric acid and sodium citrate concentration by plus or minus 10%, and then you calculate the pH for each of those values, then you start to see which of those combinations are within the 0.1 pH range, then which is within 0.2 and 0.3 and so on. So this gives you a very quick idea of what buffer concentration ranges you need to be able to control the process or your solution to be able to achieve your plus or minus 0.1 pH range. Hope this was useful, and if you have any questions, please write a note to me or drop a comment on this video. Thank you.